All right, let me start here today talking about this problem. And what we want to do is I want to evaluate a double integral. But I'm going to first need to reverse the order of integration. I've got the y's integrating first and then the x's. But the reason that's a problem is because looking at what I've got in the expression in terms of y, I've got e to the y cubed. And if you think about an integral e to the y cubed dy, just that part of it, I would be able to do it as with substitution. And if u equals y cubed, I'm going to need for my du, I'm going to need a 3y squared dy. And that's just not going to be happening here. So I would not have the same problem with this if I started with the x's, and a nice thing will happen if I do my integration with respect to my x's first. And so I'm going to reverse the order. And so what I've got here, based on this these limits of integration, is the y is running between x squared and 9, and then the x's are between 0 and 3. Okay, and so that area there that I'm integrating over looks something like this. Y goes from x squared to 9. And so y equals x squared looks like this. And then y equals 9, of course, is just a horizontal line at 9. And with my x going from 0 to 3, I'm talking about this part of my graph. All right. So now, now I want, and that starts with the y's going from, sorry, the other way around. Oh, that was right. Okay. And so we go from x squared to 9 and the y. So now I want to start with, for this part, just draw that part. So now I want to integrate first with respect to x. And so my x's, if I start with them, they're going from this line, which is x equals 0, to this, which is x equals, what would that be in terms of, solve that for x, be the square root of y, this side of it. And so my x's are going to run between 0 and the square root of y. And then the y's, of course, range from here 0 to 9, would be the equivalent over here. Okay? So if I change the order of integration, instead now, I'm doing the same function, but now I'm going to integrate with respect to x and then y. Well, it turns out the x's then would go from 0 to the square root of y, and then the y's would go from 0 to 9. Okay? All right, so let's see. Now I think I can do that because now I'm integrating with respect to x first, and so that's just x cubed. This other is constant, and so let's write it out front here. So the antiderivative there would be 1/4 x to the 4th. I'm going to go run that from 0 to the square root of y. And so if I plug in the square root of y there, I think it's going to come out really nicely. So that'd be 1/4. Be the square root of y to the 4th, which is y squared. Square root of y to the 4th would be y squared. And of course, plug in 0, just be 0. And so here's my result, which of course now if I let u be, I can do my substitution because now if u equals y cubed du would be 3y squared dy. So I've got this part, and so I just need for du, du over 3 would replace this, so I'd have basically have this. So y equals 0 to 9. I've got e to the u, and then I've got, let's put the 1/4 here. And then y squared dy replaced by du over 3, or 1/3 du. Yeah, now I can do that. That's just easy. It's just 1/12. And then e to the u is e to the u, antiderivative, so e to the u, but we know u is y cubed. And so I'm going to run that from 0 to 9. So that'd be 1/12 e to the 9 cubed would be 729 minus 1/12 e to the 0. So it's 1/12 e to the 729. Well, if I factor off the 1/12, which they sometimes like to do, it'd be 1/12 e to the 729 minus 1. Or something very much like. Okay, so let me show one more here like that. 0 to pi, y to pi, sine of x over x, dx, dy. And so again, without reversing the order here, sine of x over x, that's an impossible integral to do. And so let's switch these over and do dy and then dx. All right, so what have I got for my area? Well, this is saying the x is first, so that's x goes between y and pi, and the y goes from 0 to pi. And so that is from x equals y, which is that, to x equals pi would be vertical line at pi. So I'm talking about, and then y goes from 0 to pi. And so I believe that would be where I would start us out there with that area. So the x runs from 0 to the pi, and then I go from 0 to that corner. Okay, so now I want to first do it the other way. For this area, do the y's first, and so I'd go from here to here, and of course that's 0 to pi as far as the y goes. 0 to the y equals x line for the y's, and so y would go from y equals 0 to x, and then of course the x's run from 0 to pi. All right, and so making those conversions, I'm going to do sine of x over x now. Instead of dx dy, the dy dx, y's first and then the x. So y's go from 0 to x, and then x's go from 0 to pi. And at least anyway, first of all, since I'm doing the derivatives with respect to y, I can do that integral first integral, because those are just constants. And so I get 0 to pi. That would just be sine of x over x times y, right? 0 to x. And so that would be 0 to pi. Plug in the x, I would have sine of x over x times x minus 0. And look at that. Nicely, that just turns into 0 to pi sine of x, which is just minus the cosine of x. 0 to pi, so that would be minus cosine of pi minus negative cosine of 0. Let's see, cosine of pi is negative 1, and cosine of 0 is 1, so that's minus 1. And so we've got positive 1 plus 1, so we've got 2. Okay? Okay. Also, is it okay? All right. Let's do this one next. Find the volume of the solid that lies below Z equals 16xy plus 200 and above the region in the xy plane bounded by y equals x squared and y equals 8 minus x squared. Okay, so we've got this three-dimensional surface here. Z equals 16xy plus 200. But we want stuff below that, and it's bounded above by the region here. So let's draw that in our xy plane here. Of course, y equals x squared is that. Y equals 8 minus x squared would be that. Okay, and so those two, it's much more symmetrical than that. Yeah, okay, so I want that region there. So we're taking above that and below that. Okay. All right, so what we found is that we can find the volume by between an f of xy surface and then a region in the xy plane. We can find that volume by doing the double integral over whatever that area is, d. That's our area d here. By doing the double integral of f of xy dA. Now we have a choice here. Of course, dA, we can either do dx dy or dy dx, depending on which way we would think would be best to do first. In this case, because of the way it's set up, I think certainly doing the y's first. Y goes from x squared to 8 minus x squared to x squared. That'd be a whole lot easier than doing the x's first this way. And so that makes sense here to do our double integral of f of xy, which is this 16x y plus 200. Do that dy and then dx. Okay? All right, so like we said, the y's would run from the top one Bottom one would be x squared, and then 8 minus x squared would be the top one. And then my x's, we'll notice, would range from then wherever these 2 points, 2 graphs intersect, and that would be where x squared equals 8 minus x squared, which would be 2x squared equals 8, which would be x squared equals 4, and so that would be positive 2 and negative 2 where those intersect. So x would go from positive 2 to negative 2. And so that's my limits. The y's go from x squared to 8 minus x squared, and then the x's go from negative 2 to 2. So let's see, see about that. Doing the y's first. So this integral is, got the y, so it'd be y squared over 2, so it'd be 8x y squared, 200y. Let that go from x squared to 8 minus x squared. Okay, and so that would be, plug in the 8 minus x squared. Have to square it, the only drawback there. And then 200 times 8 minus x squared. And then plug in the x squared for the y, so it'd be 8x times x squared would be x to the 4th, and then 200x squared. Okay, and so doing all that out, see, that'd be 64 minus 16x squared plus x to the 4, so that would be 64 times 8 is 512 x. 16 times 8 is 128 x cubed. Multiply the x2 and then 8x to the 5th. And then we'd have 1600 minus 200x squared. And that would be minus 8x to the 5th and minus 200x squared. All told there. So I have a negative 2 to 2 of my largest, the 8x to the 5th cancel. My x cubed is the next one, so it'll be negative 128x cubed. 200x squared, so I got minus 400x squared. Sorry, yeah, that's 400x squared. And then 512x and 1600, sorry. I believe is what I've got there. All right, so let's move over here. So it'd be negative 128 over 4. Let's see, divide that by 4, so it'd be 32. So it'd be negative 32 x to the 4th minus, it'd be 400 over 3x cubed. 512 x squared over 2, so that would be 512 divided by 2. What would that be? 256 x squared, and then 1600x. I'm going to evaluate that from negative 2 to 2. All right. Just punch that in. All right, so negative 32 times 16 minus 400 over 3 times 8 plus 256 times 4 plus 3200, and then minus negative 32 times 16 minus 400 over 3 times negative 8 plus 256 times 4 plus minus 3,200. Comes out to be 12,800 over 3. Okay. All right.